Hey y'all, Data Guy here with a video that I've actually been working on for a long time, which is comparing Databricks to Airflow for a typical ETL workflow. So I know my past comparison videos, you guys commented, I heard the comments that it was a little too, non-practical. I didn't really delve into, hey, the functional part of each of those two softwares. And so in this time, I'm going to be completely objective. There's going to be no editorializing, no commenting on the difficulty, just a pure breakdown of what it takes to develop the same workflow in Airflow and in Databricks. And we'll look at the performance of those workflows as well. So just to show you guys the workflow that we'll be working, or the data pipeline we'll be trying to build in both of these platforms. Going to do a typical kind of just stock data ingestion. So we're going to ingest some information about some stocks. Then we're going to clean that data just to give us only the price, ticker, and volume. Then we're going to transform that data to find the highest stock price in each month in the past year. And then we're going to load that data into an S3 bucket as a staging area before copying it from S3 into a Snowflake database. So kind of mimicking, hey, after you've checked your data, you've cleaned it, you're bringing it into production. So I'll build it in Airflow first, then we'll go over to Databricks, and I'll show you how it can be built in Databricks as well. So without further ado, let's get into it. And also, if you like these videos, please like and subscribe. Always looking to bring the word of Airflow and just better data pipeline practices to more people. So now let's switch over, enough spiel, and get into the actual fun stuff. So to set up this Airflow environment, so I know I have my packages here, but just to give you the full process from end to end, I use the Astro CLI, easy way to get started running Airflow, where I just created a new directory called dbricks compare, ran astro dev init to actually pull in all the files to make this an Airflow directory. I won't do this again so it doesn't overwrite anything. And then just astro dev start to actually start this running a local Airflow environment on using Docker Desktop. You don't have to use Docker Desktop, you can use Podman as well. So that's all I had to do to get an Airflow environment up and running. And then I just created a Python file, and now we're going to go through how to actually build the same Python file to create our Airflow DAG to ingest that stock data. So first thing we're going to do, import our libraries. So getting the DAG decorator in there, the Astro SDK, AQL, table, and metadata decorators. And what those allow me to do is just export, or not export, but set pandas data frames as task outputs and pass those pandas data frames between tasks. So I don't have to have the intermediary step of, taking that pandas, bringing it into a CSV, dropping it into, either on my local system or an S3 bucket, and then pulling that back in and turning it back into a pandas data frame to do transformations. I can just pass a pandas data frame to a SQL statement, and from that SQL statement on the pandas data frame, and then return it as a pandas data frame, and vice versa. It just eliminates a lot of the boilerplate code here. Then I'm also importing Pendulum for better date time. Bootu 3 is the AWS SDK for interacting with AWS resources. So in this case, an S3 bucket. Then also pandas. So we can create and store pandas data frames, makes our data manipulation easier. And then the string IO, what this will actually do is create a CSV buffer so that I don't have to save it on, or when I'm uploading my CSVs into S3, you'll see I'm saving it as a CSV instead of a pandas data frame, because you can't upload a pandas data frame. But instead of saving it on my local machine, the string IO buffer will just create some ephemeral attached memory, store the CSV in there, and then upload it into our S3 database. So very short-lived storage. So just good. So you're not actually storing anything on your local machine, because that's bad Airflow practices. Then we also have the S3 to Snowflake operator, just to transfer that data from S3 to Snowflake without me having to just write that SQL query myself. But you probably should do that in reality. I just chose to make it easy because I'm lazy. So after we've got all our libraries in, I need to set a couple of variables. So ticker list for the stocks, I'm going to collect information for, as well as my Snowflake connection ID. So go set that in the Airflow UI, call it Snowflake DB, and then I'm going to reference this whenever I'm connecting to Snowflake at the end. As well as just setting my S3 base path, so I don't have to just rewrite that S3 base path when I'm within my actual DAG, and I can change it up here easily. And then we're off to the races. So it's time to start declaring some of our Astro SDK tasks. So the first task we're going to do is the load stock data. So here it's going to ingest a ticker list. And so we're actually going to map on this task to feed it 3 tickers, run them in parallel. But I'm getting ahead of myself. So what this will do is take this ticker and insert it into this URL, which will then pull a CSV file of stock data just from a GitHub repo I created, because I couldn't really find a lot of easily accessible API endpoints for data sets that don't require you to pay or sign up. And again, I'm trying to keep it low cost as possible because I don't get paid for this. So after we've got our data ingested, it's read in as a pandas data frame. What we'll then do is create a Astro SDK raw SQL task, just referencing our local or Postgres database. So this PG default is just my local Postgres database here. And then we are loading the stock data. So this table that was being pulled in, you can see this is being loaded in as load stock data, which we're feeding it a table, which this output, so the pandas data frame is treated as a table here. And then we're going to select date, open, volume, and name from load stock data using Jinja templating to just reference that variable of stock data there. And so now we've got our clean data set task. So now it is time to actually create some transformations here. And so now we have our transformation function where we're again reading in that pandas data frame. So you can see this is, instead of reading in as a table, we're reading it in as a pandas data frame. So when you read it in as a table, it automatically converts it to a SQL queryable table. But here we want to import it as a pandas data frame. So we are going to import it, set the index to date because we want to find, for the month, every month of the year, find the highest price. Then we're going to group those dates by month so we can do exactly that, group all the months together. Then we're going to create an empty pandas data frame that's going to store all the highest values for each month that we find. And then what we'll do is iterate through that group data to find the highest opening value for each monthly grouping. So this will give us the highest opening stock price of that stock and the day and the volume trading of that day for each particular month. And then just resetting the index because we don't need to actually have it ordered within our saved database of highest open values. Then I just have a print statement just to double check that it's correct. And before we return it again as a pandas data frame to be used by our next task. So you can see here, this is just where the Astro SDK really makes the process of returning and kind of managing data between tasks like super easy. And I'm not just trying to shill it. It's an open source project, so anyone can use it. And then what we have now, after we've got our transformed stock data, so we're going to want to bring this into S3 now. So what we'll do to do that is create another Python function, an AQL data frame one, where we are just going to read in that pandas data frame, create that CSV buffer I talked about using string IO, so you have to initialize an instance of that. Then what we'll do is choose what stock data we are going to use here. And again, we're going to map this so each time it's just going to use that ticker. Print it, make sure it's correct, and then we are going to transform that stock data into a CSV. So this is just pulling out one of those data sets from our dictionary of data sets of stock data, and which we'll see kind of how it's getting created. And then we have our AWS secret, access ID, secret key, session token to connect actually to AWS. So we're using this to create a hook, again using now down here, Bluetooth 3, so calling it S3 because why not? We're just connecting to S3. And then we're going to run the S3 resource.object. So here we're just referencing the S3 object or the endpoint where we're going to put this. So the object name here, again, we're dynamically creating this where it's stock data, price, ticker name, CSV. So it's just going to be price ticker. And then we're running the .put operation on that object we just created to put that CSV file of the stock data that's stored in our string.io buffer. So you can see that there. So we're just running get value that will return the CSV that's within that buffer. And then each of these tasks, when we run them in parallel, will have their own CSV buffer that they're using. So now we've got our stock data in S3, and now we just have one more thing to do, which is actually bringing it into Snowflake. But before that, we're actually going to need to define our DAG code because our final task isn't defined using the task API, it's just a standard operator. So what we'll do is define our DAG. And so within our DAG, it's a pretty standard one. All we're going to have is just the schedule to run daily because we want to collect that stock data daily. again, this is just kind of playing around with it. Start date, set it to whatever, catch up false. None of these are important. This is just kind of a, test out, hey, how do we build this? So here we have the load stock data, and this is where we're expanding it to not just ingest one ticker, because you notice all those, it's not ingesting a list, it's just ingesting one table at a time, to actually dynamically map tasks. So create 3 task instances for each DAG run of these tasks. So for each of our tickers, Apple, CVX, and Fox, it's going to create one task to process that data. So we're going to load it, all this data in parallel, clean it in parallel, transform it in parallel, load it. And what that's going to have the effect of is, instead of it taking the time to complete of uploading, all 3 data points at once in a larger data set, now you're completing those much smaller operations in parallel in the time it just takes to load one of those data sets. So just trying to show, hey, some resource efficiency here, because that's always, end of the day, you're getting killed on your budget. And so now after we've done that, we've got the kind of basic flow of our tasks done. And this actually, because we're referencing load stock data as an input to this clean stock data function, the task flow API is going to automatically recognize that relationship and create that task dependency. So we don't actually need to set it explicitly using bit mapping. And so once we're done here, what we'll do is create our operation to copy from S3 into our Snowflake database. So here I'm referencing that Snowflake connection ID I used earlier. I have my stage that I've set up in Snowflake as just an S3 stage. I have the 3 S3 keys that I want to ingest into Snowflake. Actually, my CV or CSV. .csv. Make sure you have the right file format, because it's pretty finicky around this. It's took me a couple trial and error times to actually get right. That you're marking as type equals CSV, and you have to have these parentheses within the outer brackets for Snowflake to accept it. I don't know why, I'm not going to pass judgment. And then we have our table of stock data. So that's just where we're ingesting all these data files. And so here, this is the only bit mapping we just set, because we're not referencing this S3 stock data. So just going from S3 into copy from S3 Snowflake. And then the only thing left to do is initialize the DAG object, and we're off to the races. So now I'll kick it back over to the Airflow UI, and we can look at this DAG running, and also just I'll show you kind of the S3 bucket and the Snowflake table to really prove that it's all working fine. So head over there now. And so here we are in our handy dandy Airflow UI. So wanted to show you what this looks like. So as you can see here, we have these loading in parallel. So it's actually loading, those 3 different tickers in parallel. And if we go into, let's say, one of the details of these tasks, let's list the instance and go to a successful run ID, task ID, and we can just look at the logs just to kind of check out, hey, what's going on here. So you can see this is just running the task execution, but actually I forgot. Interesting part is if you go to the XComs, you can actually see the pandas data frame that we are returning. And sorry, one second, let me zoom out my screen. So sorry about that, very unprofessional. So here you can see in our XComs of one of these tasks, the return values. And if we go back to the grid view, so if we hit the graphs, and now graph view is integrated into the grid view, you can see the little 3 icon to show, hey, these are running 3 tasks in parallel. And if you want to monitor any of them individually, just go to the map tasks, click a task index, and you can look at the task logs for that particular task instance. And then you can also go similarly into details and look at the rendered file as well. Now, going into our S3 bucket, you can see some of the price files that were created when I first ran this pipeline. So I've actually been sitting on this for a while, getting the Databricks part set up. So you can see those files right here under that DB compare stock data folder, and also the previous iteration, I just put them directly in the bucket. And then if we go over to Snowflake, you can see my data preview where it has all my stock data all in one data set here under stock data. So you can also split it up in different tables. That's what I'll do in Databricks just for fun. But just want to show you, so that's how we've built it within Airflow. So, one Python file takes, obviously I put more time into it than I'm showing you here, but it took me about an hour, 2 hours to complete. Just a lot of finicking around with connections and making sure everything was working together properly. And then if we go into Databricks, we can start with actually building this within Databricks now. So this is what it looked like within Airflow. So now we're going to look over on, hey, what does this look like to create the same workflow in Databricks with an eye of just, hey, which one is suited for your particular workflow? So now let's kick over there and get started. So to create Databricks, first thing I actually needed to do was provision this in Azure. And so luckily with Azure, it's really easy where I can just create a Databricks and under a resource group, and it'll automatically spin up, the infrastructure needed to actually run Databricks, because Databricks is, essentially a managed Spark cluster with a lot of tooling around it to, so you can do a lot more with that Spark cluster. And so after I'd done with that, I then had to create a compute node. So this is actually the Spark cluster that I'm running here. So 13.2 ML, certain runtime version. I just chose, the standard one. So I figured, hey, let's not go crazy with it. I don't want to spend a lot of my company's money on a Databricks cluster. So created this cluster, and then after I was done with that, it was time to start developing. So instead of creating your workflows, so I guess first your preface this with Databricks doesn't really have a local environment. So you're going to do your development within the Databricks UI. I'm sure you could develop your code externally and then bring it into here, but I figure if there's a UI for it, why not use it? And so to create kind of a similar DAG structure to Airflow, you'll need to use Databricks workflows, because otherwise everything's kind of just notebook based. So it doesn't have that dependency of, hey, this second task needs to wait for this task to complete before it actually runs. Because it's in a script, it can kind of just go like, it'll start running before that data is actually arrived, and you kind of run into some issues that way. And so after we done that, I went into my workspace and started creating some notebooks. So you'll see here, each task has its own individual notebook. So you're not going to reference a cell within a notebook, but actually an entire notebook. If I'm wrong here and there's another way to do this, please tell me. But this is kind of what I figured out. And so the first task, again, we're going to load that data. So since, again, this isn't running on a local machine, needed to save this data into that Spark cluster. So my workflow was just importing pandas. It's the only thing I'm going to need here within this notebook. Creating that ticker list, creating empty list to store the data frames I'm going to ingest from that endpoint, and then creating a for loop to read the CSV for each ticker in that ticker list, and then saving it to the Databricks file store just under ticker data CSV. Then just again, or creating the file path and then saving it to a CSV file within the Databricks file store. So pretty simple full task. And then once I'd done that, I went to go create a next task to clean data. So with this, I imported a pandas data frame, set a ticker list, set dirty data frames just to ingest all the data frames I'd be using. And then again, using that ticker list to iterate through and load that data back out of the Databricks file store using the pandas read CSV function again. Then because there wasn't at least a way I figured out to kind of mix and match Python and SQL here, all I did, there's some libraries out there that do it with Python, but why make it more complex than it needs to be? So I just did a similar kind of operation with pandas as I did with SQL and Airflow, where I just selected the date, open, volume, and name of for each particular row of the stock information. Then again, to pass my data to the next task, I had to create that CSV pathway and then load it again using the toCSV method. So that was my second task. Now I got some clean data again in the Databricks file store. So now time to transform it. And so now we have a very similar function to our Airflow environment, where again, you're just importing pandas, creating that ticker list, creating a empty data frame for transform data frames, and one for my clean data frames after this operation or that I'm ingesting. So here we have for ticker list, reading in all those clean data frames again back in from the Databricks file store, then running a for loop to for every ticker. And each ticker is the key. Each ticker is the key value. Each data frame is the value within this dictionary. So making sure that the date is of the datetime value. So making sure the data is in a format that Pandas recognizes. Setting it as the index, grouping by month, finding the highest values, iterating them to find the highest value for each month. Pretty much the same as what I did within Airflow. The only difference is here that at the end, I was actually taking that transform data and again loading it back into that Databricks file store. So similarly as I've done in between tasks, because it seems to be the easiest way to pass data in between tasks within Databricks, unless obviously I could provision an S3 bucket, but then I have to upload and download from an S3 bucket every time, and that's just kind of end up costing a lot in the long run. So now that I got my transform, it's time my data is all transformed, ready for upload to S3. So let's go do that. So here, because Databricks, there's no you're not setting your libraries for the entire workspace. You're setting them on the notebook level. So what I did was import boot23, string IO, pandas, create that ticker list again, create my transformed data frames, empty data frame again, read in my data from the Databricks file store, add them to that transformed data frames. And then here, what I'm doing is defining my AWS credentials. So you're going to, I just deleted them before I showed you this. So here, again, just access key, secret, session token, your bucket name, your S3 path within that bucket. And again, we're just creating that S3 client. And then for every, so because we're not task mapping here, we have to create a for loop to make sure every data frame gets uploaded. And it is pretty much the same as, within Airflow, you're running that, just creating a CSV buffer, transferring the data frame, that the stock data to that CSV buffer, then running the S3 put object operation to put that data into that S3 bucket. So here we're just using Jinja templating to set that pathway and the ticker here as well. So that's kind of the only slight difference. And you can see the CSV buffer get value to reference that value that's being stored in the CSV buffer. So pretty similar to Airflow. It's just a lot of more Python, and you obviously got to do kind of the manually pulling in and out of data, which definitely wore on me after a while. But I said no editorializing, so we're not going to. So now we got our data up in S3, and if I actually set a different file path, you can see here that we have db compare stock data. So I call it db compare again, where you can see the CSV files I'm uploading. And then going back into Databricks, we'll go over to our S3 to Snowflake to perform that final operation. And so here is where the Spark part of Databricks kind of got a little bit hairy for, at least this particular use case. And that is because since everything has to go through that Spark cluster, you have to set a lot of configurations for that Spark cluster to be able to interact with Snowflake. And you have to do it at the workbook level. So even if this is the Databricks file store example, and when you try to, hey, show me how to connect to Snowflake, it'll just create a kind of pre-formatted way with this SF options and Snowflake source name. And so what this is doing, starting at the top here, again, importing pandas, getting our ticker list in here, and then the Snowflake source name is telling Spark to use a configuration profile for Snowflake, which is defined by net.snowflake.spark.snowflake. And then under SF options, you're going to need to define, so similar to how you would do, within the Airflow UI to create a connection, you'll just create a dictionary of your Snowflake URL, your database, your schema, your role that has access to that database, and then whatever table you want to be referencing, and your user and password. And then also what I noticed, so this is actually doesn't come up in the documentation that much, but I ended up having to add this pre-actions to the SF options to explicitly define which database and schema I'm using. And this is because when I tried to run it without these options specified, it just wasn't able to find that specific database. It had the right role, it had the right everything, but I guess it won't know to target a particular area of your Snowflake environment unless you set these pre-actions. Again, if I'm wrong here, please, I would love to know. Someone tell me in the comments. And then similarly to the prior session, we're going to have to define our AWS secret, access, and session token. But here, we're actually needing to set a Hadoop configuration so our data can flow through that Spark Hadoop and then be uploaded into Snowflake. And so here, I had to set the configurations for access key, secret key, session token, tell it to actually use the temporary credentials instead of standard AWS profile. And this actually didn't work out of the box. So what I had to do then is also go to my compute and add some libraries. So here I had to add the AWS SDK. So this allows me to use Boot23 and interact with those S3 resources. And Hadoop, which is Hadoop AWS, which is setting that configuration profile for Hadoop to call out to AWS, take my data from S3, and then bring it into Snowflake. So within here, and kind of as you'll see in some of the timing of this, that's actually taking that data from S3, bringing it into Hadoop, and then bringing it into Snowflake. So kind of an interesting workflow pattern there. So after I had set that up, this started working. And so then I just created a for loop again, similarly to reference that S3 path of my stock data, read that as a CSV, and then set my table name. So in this case, just to mix it up. So you could, as I showed you in the past one, add them all to the same table. Also, you can make a slight change just to create one table for each stock ticker. And then setting my SF options dynamically to reference that table name. So this is adding this for just within this for loop to my SF options definition. And then what I'm doing is setting the right format, using the Snowflake source name, options, mode, overwrite, save. So it's going to overwrite anything that's already existing there. So this format is where that Hadoop configuration we set up here is actually coming into play. So Hadoop knows to use this Snowflake connection profile. And so that was all we had to do to get it all up and running within Databricks. So now I'll kind of show you within here is how you can build your DAG then. So because, as we saw, there's no explicit task dependencies set, when you're actually building your tasks, what you'll do is just kind of use, and let me just kind of blow this up here, use this little graphical user interface. So let me zoom in, where you add tasks by hitting this add task button. And here you'll reference this notebook, call it, big task, because I'm not going to save this. And then you add this notebook to say, hey, I want to have this task actually call this notebook. Since I was pretty simple, just linear task definition, I didn't really need to fuss around with kind of any branching logic. You can do that. What you'll do is just go to set dependencies explicitly, depends on, but if you just keep adding tasks, it'll automatically link it to the task you added before it. And now I was off to the races. So after that, I did a couple runs. So here we can see some actual Databricks runs. And as you can see from this duration, this is why I'm not showing it live, is because Databricks takes a while to complete these tasks. And I'm not really sure why. Maybe it's because this load data is taking a while because it's got to spin up a cluster. But you can see here, our first task takes about 4 minutes, 30 seconds. And then our Snowflake task at the end, because it's bringing it into Hadoop before uploading a Snowflake, is taking 1.5 minutes. So if we go into the log files here, we can go into the log section and see what actually happened underneath this. Why it took so long. So it looks like what's happening here is it's actually starting a driver to run my Python code and then spinning up these services before it actually starts running my workflow. I'm not sure why this is, because I did make sure the compute was spun up ahead of it. And as you can notice here, in my workflow section, I ran a pipeline directly before it. So theoretically, the compute should have been spun up, but for whatever reason, it takes a decent amount of time to complete on Databricks. It gets a little bit quicker each time. Maybe it remembers the build configuration, but just wanted to kind of call that out here. And so it's pretty long to complete a relatively simple data pipeline. If we go over to the Airflow UI, we can see that this one actually, or in Airflow, it completed in, 8 seconds. And even if we average that out over, more task runs, it is, let's close this. You can see it's like 8 seconds, 9 seconds, and 10 seconds. So maybe I'm missing something on why it's taking so long within Databricks, or maybe Databricks just doesn't handle kind of I/O super efficiently. But that is kind of my findings in conclusion. So I would say, just kind of from my perspective, Databricks seems to be really good at managing Spark jobs, but I'm not sure it's really well suited to managing external systems. Just kind of the call out process of interacting with something like Snowflake or S3, that's all code you're going to have to replicate in any task that's using that. And it's just, not super clean or user friendly. Just writing big Python scripts to have to connect to, instead of just setting some kind of connection. And so I thought, like, hey, maybe I'm doing something wrong. Maybe there's Partner Connect. But with Partner Connect, this typically is just for ingesting data. It doesn't actually help you load data somewhere else. And so I guess that's because, Databricks probably wants to keep all of its data on the Databricks platform, get more of that cache. But if you're trying to bring stuff out of Databricks into an external location, you might want to think about, using Airflow in conjunction with Databricks. So really not trying to make the case of using one or the other. I really just am trying to make the case of, hey, you should use both of these together to create a better data pipeline where, hey, maybe your Databricks is really good at running your Spark portion, and then Airflow helps orchestrate the rest of your data pipeline around it. So anyways, though, that is the end of my video for today. I'm not going to draw any conclusions here. I'm going to let you draw your own. I hope this was informative. I hope this helps someone out there make a good decision for their organization. And that's all. Have a good one. Data Guy out.